Parentheses, don't forget. 1 plus 0.053 divided by 12. Close the parenthesis. I'm sorry. Okay, parenthesis. 1 plus 0.053 divided by 12. Close the parenthesis. Caret. Now, normally for those who have an older calculator, I would recommend put parentheses. In this case, if I don't have an operation here, I'm not multiplying, adding, or anything, it's okay without parentheses. Okay, don't forget to come down from the power if you have a newer calculator, and only after that subtract 1 and close and press enter. So it happens that it's slightly, as expected, slightly higher. Let's use 6 decimal places. So we have 0.054307. So I will stop sharing. So as you see, this is slightly higher. It's 5.4307% if it's calculated compounded monthly. Okay, so this is one example. So you have reference for your homework. Okay.
So on annual yield, we always put it in percent.
Say it again.
When we're calculating the annual yield, we always convert the answer to percent.
Because it was given, very good question. Thank you very much. Because it was given to us in percentages, I don't want to compare 5.3% with 0.053. You understand? So if this is in percent, I can only compare it to percent. Now, if I change this here with 0.53, then I don't have to write the percent. So then I'm comparing these two. But since we are the annual interest rate is always given in percent, most probably, then I will compare these two.
Okay, thank you.
Thank you. Is that okay?
Yeah.
Okay. Good. Now I would like to one more example with annuity formula. So this is something that I wanted to. I don't have my calculator here, but I have a TI 86 calculator. Oh no. I'm in class. I'll call you back. Okay. Bye. Nobody calls the entire day, and now everybody's calling, and they know. But so if you want to borrow money, let's say you decide to buy a new car, or you would like to buy a condo or a home. The annuity formula that I'm going to show you, it calculates much faster than people at the bank can do it, or people at the bank understand it. Not all, but many of them, because there is really no need for them to understand this formula that I'm going to present to you. But if you want to know ahead of time how much you will have to pay if you borrow $10,000, and how much would you for 10 years, how much you will have to pay per month at a particular interest rate, you don't need to go to the bank. You use the annuity formula, and you will know right away how much you will have to pay. And then by the time you get there, you know if you can afford it or not. So it's a very useful formula. It's called the annuity formula. So I'm going to write it for you, and we're going to work with it in a moment. So here it is. The monthly payments, principal. So it's an interesting formula, not easy to work with. So 1 plus r divided by 12 raised to power n, of course, and 1 plus r divided by 12 raised to power n and minus 1. It's not an easy formula to work with. Okay. If P dollars are borrowed, of course, the same thing, principal. At the annual interest rate, R, in all these three, it's R, of course. The payment M per month made each month for a total of N months. So this N, number of months. Okay, so let's see. You can give me any amount you want to borrow. We need an interest rate, and you need to tell me how many years you want to keep the loan till you fully repay it. And then I'll tell you, I'll show you how to plug in this formula. So who would like to borrow any amount of money? Nobody wants to borrow money, but who considers at some point in time borrowing money? And how much?
20.
Say it again.
20.
Well,
20,000.
okay, let's say we want to buy a home and we want to borrow 200,000. What is the interest rate? The annual interest rate? They're quite low these days.
4.6.
Okay, 4.6 is fine. Percent. Very good. No, not 24. I'm going to erase. No, I'm going to erase that. Good. And in how many years do you want to pay back this mortgage?
20 years.
Okay, so 20 years multiplied by 12 months, because it has to be in months, right? So this is 240 months. So let's enter everything in the formula. So we have 200,000. R is, of course, 0.046. 0.046 divided by 12 and 1 plus 0.046 divided by 12 to the power of 240 months. And in parentheses, 1 plus 0.046 divided by 12 to the same power, 240 minus 1. Difficult formula to enter in the calculator. So I'm going to say this right now. We need, at the top, we really don't need parentheses because there is no another, but to be on the safe side, always remember we need parentheses for the numerator. Just for the calculator. I don't need them now, but to enter them in the calculator. And parentheses for the denominator, for sure. Because this is a product, it's okay without. But always remember, whenever there is a fraction, we should think of parentheses for both, top and bottom. Okay, difficult to enter. I'm going to share my screen. Okay, let's do this together. 200,000. Parentheses now for the top. So inside, the 0.046 over 12 also has to be in parentheses. 0.046 divided by 12. This is a factor in front. So these two parentheses are only for this ratio. This one here and this one here. Multiplied by, in parentheses, 1 plus 0.046 divided by 12. Close the parenthesis. Put a caret for the power. I will also put that in parentheses because some of you need it anyway. Come down from that power, and now I have finished the numerator. So I put this parenthesis that is paired to the one that I started with. Now I put a division symbol, and in parentheses again, and another parenthesis, 1 plus 0.046 divided by 12. Close the parenthesis. Put the caret in parentheses again, 240, because it's the power. Don't forget to come down from that power, subtract 1, and close the parenthesis. This parenthesis is paired with this one. This parenthesis is paired with this. And now, I hope for the best, and press enter. And we'll see how much we pay per month for the next 12 years, fixed every month for the next 12 years, and then we can calculate how much we pay extra on top of the 200,000. So we give them back the 200,000 and let's see how much we pay. So this will be the amount we pay per month for the next 20 years. 1,276.12. If I multiply this amount, so let me write it for you. So it's approximately 1,276.12 per month for the next 20 years. So I multiplied this by 20 years. And also, I didn't mean that. I have to put multiplication. So this answer will be multiplied by 20 years and multiplied by 12 months in each year. And this is what we are going to have pay back by borrowing $200,000 today at the end of the next 20 years. So we will be paying $106,263. That's the cost of the loan. We can minimize this by paying a little bit more every month if we can. So if we pay it off sooner than 20 years, we will end up paying less than this. But right now, if we keep the loan for its entire term of 20 years, then we get 200,000 and we pay them back 306,268.82. Any questions? And now I will say this completes R.1. Everything in R.1 is completed, and feel free to start working on R.1. The sooner you finish it, the more questions you ask, the more conversation we have, and we put it behind us. So now we are moving on to R.2. So R.1 is done. So that was your question at the beginning. Very good question. So this is completed. Now R.2 reviews functions and models. We covered much of it by the difference quotient, by evaluating, by graphing, by a piecewise defined function. Everything is done. Now I would like I cannot, for some reason, I'm not sure why, I cannot show you the book. So let's go to pages, if you have access, pages 21 through 23. I don't have any news here, you choose. So pages 21 through 23.
Everyone's going to have access. That error means that their server's down. So it's probably nobody has access.
Oh, really?
Yeah, it's a bad gateway. So
yeah, I tried to look it up, but it wasn't working for me.
It's a universal error. Nobody will be able to access it until they fix it.
Okay, very good. So then, I get to choose. Thank you. Okay, one thing that I would like to choose is problem. So you tell me, would you like, I'll read the problems because I also have the book here. So I'll read the problems to you. So we can do another piecewise defined function. If you'd like to graph another piecewise defined function, we can look at a graph or not do anything because everything was covered.
I was just going to say another piecewise.
Okay.
I was going to say the same thing.
Very good. Okay, so let's do another piecewise. Let's say 68. I'm switching now. 68 on page 23. See, the time was not wasted last week because I knew that this was part of it anyway. So, okay, so let's say 68. The function is g of x. It has three pieces. It has x squared for x less than 0. It has -3 for x equals 0. And -2x plus 3 for x greater than 0. Is this a okay one, or you would like me to choose another? Okay, Gabby, will you tell us what is the first step? We are asked to graph this function. What is for sure the first step when we graph a function?
Are you doing the difference quotient for this?
No, we want to graph. So sorry. So the
okay.
question was graphing a piecewise defined function.
I would just, because you have to figure out, like, since it's giving you like x is a less than 0.
Great job. So we need to determine the domain no matter what. So when we graph any function, if we are asked to graph a function, we have to find its domain. We cannot start without finding the domain. Can anyone give us the interval notation for this? Shvam, will you give us the interval notation for this?
Less than 0.
The interval notation. I'm plugging my computer because it's running out of juice. Amin, will you give us the interval notation for this?
Would you start with an open bracket and then 0, right?
It says x less than 0.
Oh, so it'd be negative.
Negative infinity 2. That's it. This is very clear. What about this, Jackson?
0 and then to infinity.
Very good. So can anyone now state the entire domain?
I have a question.
Yes.
If we were like writing this answer for a test, would we wouldn't write anything for the x equals 0 at negative?
No, it's just one value.
Okay.
The full domain is negative infinity to positive infinity.
Very good. Nothing is missing. Excellent. Who said so?
Amanda.
Amanda, thank you. I don't know your voices, but normally I would have known your voices and your names right away, but in this situation, it's kind of difficult. Very good. So we start a table. Which numbers have to be, oh, it's G. Which numbers have to be in the table no matter what? Or number, for sure.
0.
Yes. 0 must be in the table. And for when x is 0, how much is y? When x is 0, how much is y? Negative 3. And now I have to put two parentheses left and right. This parenthesis is this, facing left. This parenthesis is facing right. Which function we use? I know this is an overkill, but I need this for you to understand what's happening here. Which function we use from negative infinity to 0?
X squared.
Perfect. Which function? I know it's an overkill between 0 and infinity. Which function?
Negative 2x plus 3.
Yes. So the reason why I write them here is, again, this is not carved in stone. You can adjust this method if you'd like. But the reason I put them here is because sometimes they are trying to trick us. And they may reverse these two. And I may copy the wrong function for the opposite territory. So that's why this one says to the left of 0, I have to have x squared. This one says to the right of 0, I have to have this. Because again, sometimes they are trying to trick us and they do not put them in the correct order from left to right. Okay, so now I need to plug in some numbers to the left. Let's say negative 2 and negative 1. And I need to plug in some numbers to the right. Let's say 1 and 2 and 3. So please plug in negative 2 and tell me what you get. Let's say Brianna.
4.
Excellent. And with -1?
1.
Perfect. What about with 0?
0.
Exactly, and it has to be right here in parentheses. What type of point will this be?
Open.
Excellent. What type of point will this be?
Closed.
Of course. Excellent. Perfect. Now let's plug in 0 in the other branch. Oh, no. No, I'm not going to answer. Okay, so let's plug in 0 in the other one. What do we get?
3.
3.
Very good. Let's plug in 1. What do we get?
1.
Very good. Let's plug in 2 and then 3. Very good. And with 3? Excellent. Do we all understand the steps?
Yes.
What type of point will 0, 3 be?
Open.
Open.
Of course. Only this one will be a full. This will be an open point. And this will be an open point. Why? I'm not allowed to plug in 0 here. I'm not allowed to. There is no equal symbol. I'm not allowed to plug in 0 in this function. There is no equal symbol here. I'm not allowed to plug in 0 in that either. I can only plug in 0 in this, which I don't even have anything to plug in. It's -3. So these will be 2 open points, and this will be a full point. So let's graph. Now careful, we also have to remember that this is quadratic, and this is linear. Linear, quadratic. Okay, so from left to right, the first point is, anyone?